IIT Sure. Question number 52. Two forces P plus Q and P minus Q make an angle 2 alpha with one another, and their resultant makes an angle theta with the bisector of angle between them, so that P tan theta equal to Q tan alpha. Here, let the given forces P plus Q and P minus Q are represented by OA and OB respectively, such that angle AOB equal to 2 alpha. So here we write angle AOB equal to 2 alpha. Now complete the triangle, sorry, complete the parallelogram. So here, if this OB equal to P minus Q, then this AC will also represent P minus Q. Similarly, this will represent P plus Q. Now, here OD makes an angle, this is OD, makes an angle theta with OC. So this angle is theta. And this OD is angle bisector. So we can say that BOD equal to DOA. So if this angle is theta, so this angle will be alpha minus theta. That is angle COA, angle COA will be equal to alpha minus theta. Now BOC will be, since this portion is alpha and here this portion is theta, then angle BOC will be alpha plus theta. So angle BOC will be alpha plus theta. Since OACB is a parallelogram, so angle BOC must be equal to angle ACO. In parallelogram OBCA, angle BOC equal to angle ACO, alternate angles. Now we consider triangle OAC, that is, we can write so this is P minus Q and this is P plus Q. This angle is alpha minus theta and this angle is alpha plus theta. Now we can apply sine law. What is sine law? Sine law is like this. If this side is A and this angle is capital A, if this side is B and this angle is capital B, and if this side is C and this angle is capital C, then rule says side divided by sine of angle opposite to it. That is A upon sine A equal to B upon sine B equal to C upon sine C. In our case, situation is like this. Here, this angle is alpha minus theta, and this angle is alpha plus theta. This is P minus Q, and this is P plus Q. So now we write it. So P plus Q divided by angle opposite to it, that is alpha plus theta, and sine thereof. So sorry, sine alpha plus theta, and equal to, then P minus Q divided by sine of angle opposite to it. So it will become sine alpha minus theta, or P plus Q divided by P minus Q equal to sine alpha plus theta divided by sine alpha minus theta. Now, using componendo and dividendo, if you remember componendo and dividendo, so it is like this: if P upon Q equal to A upon B, then if we apply C and D, so it becomes P plus Q divided by P minus Q equal to A plus B divided by A minus B. So we are going to make use of this concept. So we will get P plus Q plus P minus Q divided by P plus Q minus P plus Q equal to sine, should be sine alpha plus theta. So sine alpha plus theta plus sine alpha minus theta divided by sine alpha plus theta minus sine alpha minus theta. If you remember the rule, sine A plus sine B, so this gives 2 sine A plus B by 2 and cos A minus B by 2, and sine A minus sine B gives 2 cos A plus B by 2 sine A minus B by 2. So we can make use of these concepts. So here in LHS, we will get 2P upon 2Q, that is P upon Q. We can write it P upon Q equals, here if we apply formula, so it will become 2 sine this theta plus alpha plus alpha minus theta by 2, that will give just this will, according to this formula, A plus B by 2, it will give sine alpha, and then cos here, so alpha plus theta minus alpha, and this minus will become plus, so alpha will cancel out and theta will be left. So theta divided by, here according to this formula, 2 cos A plus B by 2, that is 2 cos alpha, and then sine theta. Now 2 will cancel out. Sine alpha divided by cos alpha will become tan alpha, and sine theta upon cos theta will become tan theta, which we can write in denominator, and then we make cross multiplication. So we get P tan theta equal to Q tan alpha which is desired answer? Let's give a quick review. So here the question is, two forces P plus Q and P minus Q make an angle 2 alpha with one another. So here one force is acting along OB, another is acting along OA. So we have completed the parallelogram, and this is direction of resultant, and then this is bisector of angle. So, and this makes angle theta with the resultant. So this the remaining angle will be, since this is alpha, then here theta is subtracted, so alpha minus theta, and this upper angle, that is BOC, will be alpha plus theta. So here angle BOC equal to angle ACO, alternate angles of parallelogram. So we have got the relation. So now we consider this triangle OAC. So here I have redrawn it. So this is alpha minus theta, and this angle is alpha plus theta, and this side OA, which is P plus Q, and this side AC, which is P minus Q. And here we are going to apply sine law, according to which side divided by sine of angle opposite to it is constant. So it is drawn here. So A upon sine A, here, as you know, as I told you earlier, that if this side is A and this angle is capital A, similarly, if this side is B and this angle is capital B, and if this side is C, this angle is capital C, then if we are considering this side, it means we have to take a sine of angle of this. So A upon sine A equal to B upon sine B equal to C upon sine C. So same concept we can apply here. So if we consider this side P minus Q, then angle opposite to it is alpha minus theta. So we have written P minus Q divided by sine alpha minus theta. And when we consider side P plus Q, so angle opposite to it is alpha plus theta. So that P plus Q divided by sine alpha plus theta. And then I have rearranged it. That is P plus Q divided by P minus Q equal to sine alpha plus theta divided by sine alpha minus theta. Now we are going to apply componendo and dividendo. And as I told you, if P upon Q equal to A upon B, when we use componendo and dividendo, then it becomes P plus Q divided by P minus Q equal to A plus B divided by A minus B. So after using C and D, we get P plus Q plus P minus Q divided by, and hence we simplify. Here also in RHS, we have applied formula sine A plus sine B and sine A minus sine B, and hence we have got the result. Thank you.